Okay, nampak tak slide saya ni? Nampak
Nampak.
Okay.
Nampak doktor.
Okay, tak apa, it's okay. Assalamualaikum warahmatullahi wabarakatuh, and a very good day, a very good morning to everyone who attended this class this morning. And sorry, apologize for the technical issues, and hope someone can alert those in the previous Google Meet session to come to and to join this one. Okay, for today, I will just try to run the synchronous class for the new topics, which is a breakdown in liquid dielectric. This one for me is not that extensive. It's very simple, and some the most important has been covered in the gas dielectric breakdown. Okay, and for today we will continue with the breakdown in the liquid dielectric. For those, I'm aware that most of you just completed your defense proposal for your PSM, but that is fine. And for those who still haven't finished, we've got a recorded version for them, so shouldn't be any issue lah. Just matter they just unable to ask questions during the session. Okay, without further ado, I'll just proceed with this one. Again, I would like to acknowledge that this slide is belong to Dr. Maknur Ramdan. If you can see here, Dr. Ree. And then I'll just use whatever been prepared by him. And we have 4 sections altogether, and all the 4 sections will just use this slide. This slide will be the reference for all sections. Even though those with Dr. Ree, myself and Dr. Fairuz, we all together will just use this slide, okay, to avoid any discrepancy. Okay, first overview, I will just give some overview on the liquid dielectric, general introductions, and then we'll talk about some problem related to liquid, which is breakdown. It's a problem lah. And then we proceed next with some process or phenomena that occurred in the liquid dielectric that lead to the breakdown. Okay, we have the process within the liquid, the movement of liquid and contamination particulates, cavity formations, and chemical reaction. Okay, this one, okay, an introduction. Okay, as I explained before, there are 3 main categories of dielectric material, which are gas, liquid, and solid. Okay, each type of this category will be used depending on the applications. Some of the gas are used in the switch gear, in the for example in the substation, and for the solid or liquid we use it in the transformer, because example of transformer oil. And some of the solid dielectric will use it as an insulator, suspension insulator. So each type of gas will depend solely on the application that we're going to use. And some of them we can actually combine them. We combine the gas, for example, gas, liquid, and solid in one application. For example, transformer. Nanti later on I will just explain briefly on these matters. Okay, as we learned before in the gas, we know that the formation or the initiation of breakdown phenomena in the gases or even in solid and liquid is actually from the formation of electron. Formation of electron and avalanche. This is the main causes for the breakdown to occur in the gas. It is what we term as the ionization of the gas, of the material, of the dielectric material. This is the process in which trigger for the total breakdown, mostly in gas, solid and also in the liquid. Right. For liquid, and but for liquid, the theories or findings on the exact breakdown causes is still remain inconclusive. Means that there is lack of research on this one, on this particular on the liquid, to study on the breakdown phenomena due to the less interest for the liquid. But we have some fundamental theory to explain the breakdown phenomena in the liquid, but not as detailed as what we presented in the for the gas. For example, during the from the Townsend, from the streamers theory, and for the Paschen law, they have several researcher that work in the gas to understand the breakdown phenomena. And in fact, this principle partly can be absorbed or almost similar to the one that occurred in the solid or liquid. Okay, as compared to the just overview, as compared to the gas, for example, we can say liquid should have higher density. Obviously, liquid is higher density than the gas, and solid dielectric material should have a higher density as compared to the liquid. Okay, and each of these type of the gas of these dielectric material have their own function, their own function. For example, okay, we are using liquid dielectric, for example, to occupy the space or to fill up the gaps within the transformer. We cannot use the solid dielectric because we want the dielectric material to fulfill or to fill up all the gaps within the transformer. And for example, we cannot use the gas to use as a suspension insulator. Why? Because we need the solid insulator to hold the transmission tower and the transmission line. So each of them have their respective function and purpose. So for example, we have the liquid. Okay, liquid. Why we use liquid? Because it's a better coolant. For the transformer, because it's like a cook oil, means that we need to have some sort of a good coolant system, and that can have a higher density, in which it will have the properties of self arc quenching. Self arc quenching ni adalah once we have the arc formation, the trigger of the discharge, this liquid, for example, have the capability to quenching, to diminish, to remove the arc within the material. Some material it will propagate, and for the liquid it will just will have the arc, and then it'll just quenching, so that the we don't have the breakdown or the failure within the material. That is the ideal case. Okay, for example, we have the transformer, we have the transformer oil. Imagine how we can use the solid dielectric material to fill up this transformer while it is in the tank like this one. Okay, so, and for some other purpose, this one we need to serve as a coolant. We need to provide the cooling system for the transformer, and we need the convection, the movement, the oil within the transformer. We cannot go for something that is static. Why we cannot use the gas? Agak-agak kenapa? Why? Within the transformer. Sorry. Saya tak dapat access nama ni. Sekejap. Just 1 minute. Okay, so sorry, you all masih dapat access, dapat tengok slide ni?
Boleh.
Boleh slide?
Boleh Doktor.
Okay, thank you. Okay, kenapa gas kita tak boleh guna? Can we use the gas as replacement of oil? Anyone? Seorang? Nah, kebetulan. Do. Tadi kebetulan
Flammable.
dengan saya. Sebab apa?
Tak edit tu.
Okay, Do, cepat Do. Almedo, Josephine. Hakim?
Tak pasti doktor, kurang
Tak
efisien.
pasti. Okay, actually we can actually use the gas sebenarnya. Tak ada masalah pun. Gas pun have the same characteristic to the oil. The gas can fill up the space within the tank. Similar to the liquid, it can also have the capability of to fill up the gaps. The only difference is that the only difference is this is the higher density. Liquid will have a higher density as compared to the gas, and hence, higher density as compared to the gas, and hence we can actually have a relatively smaller size of transformer. Otherwise, you might end up about a MIV size of transformer with the oil. You can end up a trailer, a lorry size of for the transformer by using the gas, because of the quenching capability and the higher density and higher dielectric strength that make the difference whether we want to use the oil or the gas. So the answer is boleh. Yes, we can use the gas, but you end up with a very big transformer tank. And by using the mungkin for example, we can have this small size bottle with the oil, and then you will end up about about a maybe car size by using a gas, and that is the difference. Okay, oil as a choice of liquid dielectric transformer, and some we are using oil to wet this the paper, insulation paper, and then we wrap it over the cable. So we applied the oil. The reason is that we want it to be to fill up the space, to fill up the gaps, or to fill up the space within this insulated paper, so that we can improve the dielectric strength and the capability for this cable to resist the current flow. We can use gas. Yes, we can actually use gas, no problem. We can use the normal air, no problem. But the we will not have the enhanced capability of the dielectric strength. It's not as high as this one. This is what we call as the combinations of solid. Solid, this is paper. Solid insulation, we have the silicon rubber, and we have the liquid as well. Liquid within the insulated paper. To enhance or to improve the dielectric strength. Okay, power cable. We use the liquid dielectric in the capacitor. A problem with dielectric. In general, the problem with the dielectric is similar to the one in the gas dielectric, in which we have the problem of the breakdown. Okay, the breakdown activity. The reason behind it is that there is very minimal research work on the liquid and solid to study the phenomena of the breakdown. Most of us just rely on the breakdown phenomena in the gas, because the gas is the principle to describe the failure in the dielectric material by the formation of ionization. the movement of electron from its atom. That is the physics to describe the ionization within the gas, and the same principle can be used to describe those what happen in liquid as well as solid. Okay, the same principle, but in this scenario we will look into several phenomena in which can be categorized that will lead to the formation of breakdown of the liquid dielectric. Okay. uh, uh, okay, problem again, the problem with the liquid dielectric, if you can see here, liquid on molecular scale are more dynamic as compared to the gas. Although they are homogeneous, uniform in composition, but they are more dynamic in terms of the molecular scale. Molecular scales means that if we want to talk about the atom, the proton, the molecules or electron within the material, it is more dynamic. What we meant by more dynamic is that the formations since they are solid, the molecule within the liquid is more stable and they are not moving. That's why they consume a very specific or space, and they have the higher electric breakdown and higher density. Okay. All right. And for a liquid, it's very hard to keep the liquid clean from any moisture, any contaminant, any dust or anything. It's very hard. That's why we encapsulate the transformer oil within the tank. Although that will also expose to the dust from the electrode or the component within the transformer. So we cannot eliminate to maintain a very clean liquid dielectric. And another issue is that we cannot get rid of the moisture. Once you get once you've got the liquid dielectric heated to a certain level, it start to form what we call it as a bubble or moisture. Moisture or bubble or void within the liquid, within the material. And this is unavoidable for the issue of the liquid. Okay, conduction process that lead to failure in liquid dielectric. Okay, we understand some principle in the gas. How Townsend described the formation of breakdown and streamers, as well as the Paschen law to describe the breakdown within the gas. We can also have some process that can be seen in the liquid that lead to the failure of the dielectric materials. Okay, but the principle is that some of the failure within the liquid also triggered by the ionization of the material. It's not to say in terms of the gas, it is ionization within the liquid. Means that an atom will have the electron that escape away from its stable conditions, and this electron will collide with another electron and will collide with another proton, and then that will somehow trigger for the formation of the conduction process. Conduction process within the dielectric. Okay, we look into 4 categories: process within the liquid, and then the second one, movement of oil or particulate contaminant, and then cavity formation and chemical. Okay, conduction process within the liquid. Okay, again, as I mentioned, any conduction normally is triggered by the ionization, ions. Without ions, we will not have the current conduction. And without current conduction within the dielectric material, we can term that the insulation material is not breakdown. So the moment we have the current conduction within the dielectric material, that is what we term, or we call that breakdown phenomena within the dielectric materials. Okay, what trigger the ion? What trigger the formation of ions? Sorry. Okay, what trigger the formation of ions is that actually part of it is high electric field, high field across the conductor. Okay, of course, within the tank, for example, a transformer, we have the, what we call it, we have the transformer oil, which is the liquid dielectric materials. And within the material, we will have a terminal that is connected to the ground, and there are also terminal that connected to the high voltage. For example, the coil, winding, and etc. So based on this one, based on once we have the potential difference between two values, high and low, then the area between the two electrode will develop electric field. That is how electric field is developed. The moment we have the potential difference, definitely we will have a electric field between the electrode, between the gaps. So okay, this electric field is totally depends on the magnitude of the potential difference. The higher the potential difference, the higher the voltage level, the higher the electric field. Okay, those I do believe you all have done a simulation work in Power Lab 4, and how you establish the electric field by using the FEMM, finite element method software. And then you can see at the sharp edges, you will see the line are concentrated, in which that is indicate the high electric field region. Okay, by this action, okay, conduction within the liquid can be triggered. Right? Okay. And another issues is that the conduction, conduction process in this one, okay, particulate defect. Okay. For example, we have the metallic particles. Okay, metallic particles from the winding, from the wall of the tank, from the top and the bottom of the tank. We will have these metallic particles. Okay, that will deposit onto deposit, or that will move within the liquid, and then it will this phenomena will trigger for the discharge formation, discharge within the dielectric material, and hence it will degrade it. Okay, degraded the insulation oil. Means that, okay, once we have the metallic particle, for example, when this small particle come to the high voltage terminal, okay, this somehow can trigger for the discharge activity within the liquid dielectric. Although it is small scale, at with time, at the end, the transformer oil will become degraded. Maksudnya the values will become the dielectric strength will be reduced and need to be replaced. And that is how the premature degradation within the liquid dielectric. Right, and then okay, conduction. Second one is the conduction due to the movement. Of course, okay, kalau if we boil a water. If you boil water in the glass kettle, you can really see if the terminal, the heated terminal, the heated plate is at the bottom. You will see the movement of the water. It start to move, start go back and then coming down, go back and go up and coming down. That is the movement of liquid. The same goes to the the movement of oil or liquid within the within the transformer oil, transformer tank, for example. Okay, and this can be categorized into 5 category. We will explain it in terms of these 5 category. First is that dielectrophoresis. Okay, we term it as a dielectrophoresis in liquid. Okay, what is dielectric phoresis? Okay, you don't need to worry about the detailed explanation on this one. It's just the matter we want to know what are these process and what are these phenomena that lead to the conduction of movement that lead to the the breakdown of the liquid. Okay, dielectrophoresis is actually attraction force that is exerted to the dielectric particle when subjected to the non-uniform electric field. Okay, non-uniform electric field, okay, as I explained before, how it can happen. It can happen due to many things. First is because of the structure within the okay, within the transformer, that is the non-uniform field. It could be happen due to the formation of many ionization within the material. It could happen due to the movement of the oil within the metallic particles, and it could be many things. And this non-uniform electric field will exert will trigger the one we call it as a attraction force. Okay, once this happen, dielectric process happen, this attraction will pull. Okay, it will attract more and more metallic particle within the material, within the liquid, and then it will deposit on the certain base, and then this will trigger for the discharge activity within the liquid dielectric. Right? Okay, and once we have this one, once the metallic particle is accumulate at one area, this will lead to enhanced electric field. Okay, the electric field will become greater, and then that will trigger the localized discharge. Means that we will see the discharge activity will happen at that particular place. It's not breakdown. It's just a discharge, but the discharge activity with time, if it occurred very long or continuously within the material, it will degrade the dielectric materials, the function of the dielectric material, and it will reduce the strength, the dielectric strength of the material to become not similar to the original. All right. Okay, another thing, due to the force, dielectrophoresis also will lead to the formation or combination of droplet of water. We have a small gap within the liquid, and then this small gap can be accumulated due to this attraction force to form a relatively larger void that will trigger for the discharge activity. Okay, this localized discharge normally will happen at the surface of the electrode in which we apply the high voltage. Okay, of course the air bubble, the particle will move within the liquid, and at some point it will reach to this high voltage value, and that is where we call it as a localized discharge will normally happen. That will deteriorate the function or the capability of the liquid dielectric. This is these are the early indication, the early process that lead to total breakdown of the liquid. Okay, force or natural convection. Okay, convection maksud by the names here, the convection is the movement or flow. Okay, movement. Wait. Movement flow via force. Okay, either by pump or natural. That's why it say force and natural convection. Convection is the movement of the water within of the liquid within a container. As I mentioned before, if you heat if the water is being heated in the glass kettle, you can really see at the early stage before it's become boiled, you can really see the water nicely move up and down, circulate within the kettle. That is what we call is convection, the movement of liquid either by force or by natural. Okay, by natural means that we know that once the liquid getting hot, and it will gain an energy, and hence it'll become a smaller molecule will become bigger. Okay, bigger it means it'll become lighter, and hence that molecule tend to go up because it's become bigger and it's become less density, less dense, and it will rise up to the top, in which the cool particle will become down because it's heavy. That's why from this movement, it will start to circulate. It will start to circulate within the container. Okay. Okay. Once we have this one, convection, as I explained before, this convection will take the defect. Like I mentioned, the defect or maybe the metallic particles from the bottom to the top, and from the top to the bottom, from the right to the left, left to the right, and this process will somehow making worse to the liquid dielectric characteristic, in which it will trigger for the premature or degradations. Next is that thermal convection. Okay, this is force or natural. Okay, this is thermal. This is exactly what I meant by a glass kettle. Once we have it's become heated, it'll become the heat energy from the heat will be transferred to the molecule in terms of the kinetic energy, and hence it will trigger for the movement of the convection within the materials. Okay, the heating within the liquid dielectric can give rise to the temperature and as well as the conductivity. Okay, once it's getting heated, and then the conductivity also will be increased. Okay, once the conductivity increase, obviously the chances to be, to have the current flow or to have a discharge within the material will be higher due to the higher conductivity, and then this will lead to a formation of current conduction. In this way, we call it as a thermal runaway. Means that we have a certain path that have a very high conductivity. Once we have the enough energy for electron to escape away, and it could actually go through this thermal runaway to trigger for the formation of formation of current conduction, or in other words, we call it as a discharge. Walaupun at the certain stage it will just quenching, it will just dissipate, but with time this discharge activity will destroy the properties of the dielectric materials. Eventually will lead to the failure. Okay. Okay, transformer is considered as a cook condition. Maksudnya means that it is hot. it is about maybe 70, 80 degrees Celsius oil, depending on the applied voltage or current, the operating current within the transformer. Okay, thermal convection. Okay, this is a cooling method in power transformer. We have four category. The most popular one, ONAN, ONAF, OFAN, and OFAF. Okay, this abbreviative is derived from this one: oil natural, air natural. Okay, means that we expect for the oil within the transformer or the liquid within the transformer to move naturally. Means that the air outside the transformer to cool down the tank of the transformer naturally. So we don't need to use a fan, we don't need to use a pump to push the oil and the air to cool down the transformer. You just rely on the gravity and the surrounding. Okay, then we have ONAF, oil natural, air force. Oil natural means that the transformer oil within the tank is allowed to move naturally, but in this case we use the external fan to cool down the transformer from outside. So we use a fan and blow a wind to the wall of the transformer, and then the liquid dielectric or transformer oil that close to the tank with the air blown through it, it will become cool, and then hence it will circulate within the transformer. And then we have oil force, air natural, or fun. This is not really popular. The one that is popular is actually ONAN and ONAF. These two, these are very popular, being used in practice. Okay, in this case, what happens is that they just rely on the natural air, natural wind outside, but within the tank, we use a pump to force mineral oil or transformer oil to circulate within the tank. Let's say this is a tank, we have the pump to pump in and out. It's like the water in the aquarium. For example, you suck out the water and pump out the water, and then you force to force the circulations of the liquid within the within the container. And we also have the OFAF, oil force, air force. So by the definition, you can actually see that we use a water pump, we use pump for both, and fan for the external. Okay, these are mostly for the high kVA rating. The one that ONAN is normally used for the low kVA because it's less critical. Okay, it's less critical means that the heat generated from this low kVA is not that significant, so it just rely on the natural, in which, for example, we use ONAF, OFAN, and OFAF. This is for high kVA rating, in which the transformer oil within the tank can easily get heated, and then we need to use external factor in order to cool down the transformer within the tank. That is for high kVA rating, high power rating, right? Okay, electroconvection in liquid. Okay, electroconvection. By looking at this one, convection is the movement of liquid within a container. By simple definitions, electro means that the movement of the movement of this liquid triggered by electric, either electric field or mostly electric field. Okay. Electroconvection process, space charge. Okay, space charge. Space charge generated in the liquid is subject to mechanical force. Mechanical force means that the pulling factor or pulling pressure by the applied electric field. Means that once we have the non-uniform electric field, a high electric field, this will somehow produce or trigger force to generate or to trigger for the convection liquid. So we have okay, then it will move within the tank. And last option, last is the static electrifications. Okay, static electrifications means that this will occur based on electrostatic charge. Okay, okay, which means the liquid are moving across the surface of material. Okay, electrostatic charge, the simplest for you to understand is the phenomenon in which you rub between two surface. Say for example, you rub your hand here, and then you put your hand to your hair. Sometimes some of your hair will attracted to the charge surface. This is exactly the same like this one. Okay, so means that the movement of the particles, okay, the movement of the particles within the tank somehow is moved to the right and left, and then it trigger the electrostatic field. Okay, this electrostatic field will trigger for the movement of the within the liquid, will trigger for the ionic conduction. Okay, since we have the charge, we have the static charge, and then this static charge will trigger for the formation of discharge, electric discharge. Okay, especially for the metallic structure. So molecule will pick up positive and negatively charged and so on. Okay, there are five approach, five method for the conduction. Okay, for the movement, we call it convection. Movement of oil, movement of liquid dielectric within a space. In this case, is the best analogy is within the transformer. So we have the conduction due to the movement of oil, and the movement of oil can actually happen due to this five process: dielectrophoresis, forced or natural convection, thermal convection, electroconvection, and static electrifications. Okay, we have these five method, five approach process that lead to the movement of liquid dielectric within the materials. And then now we will look before we finish for this liquid. And then we also have the conduction due to cavity. Okay, due to cavity formation. As I explained before, within the liquid, we cannot avoid the formation of cavity, which can be due to the heating process. Somehow once we've got a gas trap within the tank, definitely once it's getting once the tank getting heated, this one will somehow form a bubble within the oil. Okay, and also sometimes there might be a gas decomposition from the material like H2O, and then it will become a water void, or it can be a void. It can be a gas void. Okay, the formation of void, this is what we call as cavity. Cavity means a void within the material. Okay, once we have a void, obviously the dielectric strength will be different, and then different permittivity, different conductivity, and hence that will trigger localized discharge within the void. Once we have localized discharge, this can be bigger, and so on. That is more critical if the void go to the high voltage terminal, because with the high voltage terminal, we will have the high electric field, and with the current, that could trigger a relatively a more intense discharge activity within the gas, within the void. Okay, and then that is due to cavity. And last is that the conduction. conduction of electric charge due to chemical reaction. Okay, the chemical reaction, for example, we have liquid with different permittivity, different chemical compound, and different properties. This will usually lead to the failure of the insulator. For example, okay, oil molecule is chemically changed. For example, oil molecule can chemically change into more carbonized molecule. Okay, once we have carbonized, means that it is easier for current to flow. Means that carbon here means it will trigger or it will promote to the current conduction due to the discharge activities. The chemical formation within the material will develop, for example, carbonized molecule will develop the third, what we call it, undesirable gases within the materials, and they also will produce undesirable molecule within the material that may have the characteristic to trigger or to facilitate the current conduction within the insulator. That is the process that usually lead to the failure of the insulator. Although of course, why we can actually understand the breakdown within the gas is just the matter. The gas, we can we can have the gas chamber, a clear gas chamber, and then we can really see what's going on, what's happening. Okay, like for liquid, it is very difficult to we can have the glass chamber as well, but the problem is that sometimes the color of the gas is the color of the dielectric material is not really a clear water, a clear crystal clear. It can have some color like orange, like yellow, and this will make the visibility of the discharge is very difficult. But if we have a small container and we put the electrode within the material, definitely you will see the discharge within the material. We can see that. In fact, we conducted the experiment in the high voltage lab by using the transformer oil to study the breakdown phenomena. Yes, we can see the arc or the breakdown, the total breakdown within the material. Okay, once it's breakdown, all the material next to the breakdown path will ionize. If we didn't take out the voltage, the applied voltage, definitely this one will trigger for another breakdown formations, like a root that cascaded between the two electrodes. Okay, just to summarize on this, actually we have gone through this process, these four process. These are the process that lead to the current conduction within the liquid. Okay, these process are the process that lead to the current conduction within the liquid. Okay, how this, because the current conduction within the liquid is the initial stage before the breakdown in the dielectric, before the aging of the dielectric materials. Of course, it will not it will not destroy instantly, but with time, the liquid dielectric will degradated and it will aging, and at some point after 5-10 years, for example, the transformer oil in the service, sometime at a certain stage we need to replace all of this transformer oil. Early treatment for the transformer oil, for example, what we can do is actually we filter out Okay, for the maybe for 2 or 3 years service maintenance, we just pump up the transformer oil, and then we take it to the filter. We try to filter as much as we can all the metallic particle, and then pump it back to the transformer. That is what we call as transformer oil filtration. The reason behind it, we want to get rid all of this metallic particle in order to avoid the conduction within the liquid dielectric. We have these 4 categories that normally trigger for the conduction. And we have these 5 process that lead to the movement of oil. The oil within the transformer can move is driven by this process: dielectrophoresis, force or natural convection, thermal convection, electroconversion, and static electrifications. I think that sum up on the topic of breakdown in the liquid dielectric. Okay, as you can see here, kalau you tengok dekat sini, this is the example of the breakdown within the material. We have the 2 electrode and we have the breakdown, and this is actually the oil. Okay, this is the oil, this is the breakdown. The breakdown within the material, and this breakdown will trigger once we have the breakdown between electrode. Somehow you will have the metallic particles that will drop at the bottom, right? Because this spark will somehow erode this electrode. In other words, kikis lah. Sikit dia ambil, mungkin just in micro scale, in milli scale, a small particle here, and then it accumulate in the bottom, and then once we have convection, this one will trigger for the movement of this metallic particle, and that will cause a serious problem to this transformer. Okay, I think that's all for this topic. If you have any questions you want to ask, you may ask. Alternatively, it's more than 1 hour now. So ada questions tak? Any questions? Ni nak tanya pasal, okay, one is about this one, dielectric. It's very simple, sikit je. Fundamental studies on the dielectric for the liquid. Just there's some process in that lead to the current conduction, and or you may want to ask anything about the assignment of the project or anything on the previous topic on the gas dielectric. Any questions? Amir Ayat ada soalan? Amir Ayat. Gimana Amir? Okay. Daniel Hakim ada?
Tak ada doktor.
Tak ada. Liu Heng Long.
So far so good, doctor.
So far so good. That's very good. Okay, what most important, part of it, I think what, even though the lecture note is very comprehensive and very textual, I think you just try to grab the gist of the breakdown, phenomena in gas, liquid, and solid. That is just some fundamental, some of it maybe it's just additional for you, or maybe it's just a complementary notes for you. But what most important for you to understand, when we talk about the high voltage, we are talking about a good insulation. Okay, the good insulation means good dielectric material, and however, that is not always the case. The biggest problem with the dielectric material is the failure of the dielectric material, in which we expect the dielectric material to resist the current flow, but on the abnormal condition, the insulator can conduct the current. Okay, conduct the current until to a level that could trigger for the total breakdown, for example, or maybe we'll have some sort of corona, like your friends asked last week. Corona on the metal surface. We have a discharge. No problem. We have discharge. It's normal. But the problem is that the discharge activity with time, the constant formation of discharge, that will trigger for deterioration, the aging. Maksudnya insulator kita lebih can easily get destroyed. The properties, the strength is less and less. And that is the challenge on the breakdown in the dielectric material. This is very important for the high voltage technology engineering because we are dealing on the high voltage. All right. You can read the notes. Obviously, you can read the notes for better understanding, for better clarification on certain things. But anything that you need a clarification for me, you can ask here, or maybe you can ask in the chat box, or maybe you can ask later once you go through the notes for the previous recorded video, and I will try to address it. Explain to you in the simplest way, in the simplest mean. I don't want to go to the very technical, like on the physics aspect, like valence band, like atomic. We try to talk, make it very simple for easy understanding, including all the formulations, equation, and etc. Okay, kalau if you don't have any questions, I think we'll just stop at this point. Okay, ada soalan tak ada? Atira Umar ada? Tengah lunch ke apa Atira? Fatina Jiha, saya tengok yang depan-depan ni je lah.
Tak ada, Doktor.
Tak ada? Oh, bertenaga suara awak. Fatihah, Nurul Fatihah.
Ya, Doktor.
Ya,
Tak ada.
Tak ada.
Tak ada
Okey,
lagi.
saya pun tak nak paksa lagi lah. Dah tak ada nak paksa apa kan. Dah faham semua. Mungkin mudah sangat kot subjek HV ataupun simple kan. Tak ada apa. Just a fundamental. Okey. Kalau tak ada apa-apa, tadi saya siapa? Luqman. Luqman, boleh stop recording. Nanti please share the link dengan saya lah untuk saya upload balik dalam Google Drive. InsyaAllah we'll see again next week on Thursday. And saya akan I will try to record the video on the solid, and then after we finish the gas, we'll come to the high voltage generation before the mid semester break. Okay. After the mid semester break, will be continued by Dr. Fairuz lah. Alright. As of now, belum ada. I have nothing to update you on the test or on the quiz. Once I've got the info on that, I will try to address with all of you. Okay. Alright. With that, thank you. Assalamualaikum and have a good day.